Welcome to this video which covers the full solutions to the practice questions from the area lesson in the vector series. In the first question, we are told to determine the area of a parallelogram ABCD provided its A, B, and C coordinates. So let's draw it out first. So usually a parallelogram will have 4 sides. And we're going to have A, B, C, and D as the 4 points. We know that the area is going to equal to the cross product, or the magnitude of the cross product of 2 vectors that share the same points. So in this case, we have to use these 2 sides over here, and without drawing it, it's a little bit hard to see. So we're going to use this vector, and we're going to use this vector over here. So the area is going to be the magnitude of the cross product between vectors BC and vector BA. Well, first we need to find those vectors. So vector BC is going to equal to the coordinates of point C, -1, 4, -2, subtracted by coordinates of point B, which are 2, 5, and 3. When we do this, I'll actually write it here. -1 minus 2 is -3, 4 minus 5 is -1, and -2 minus 3 is -5. The other vector that we need to find is vector BA, and that can be found by using coordinates of point A and subtracting it by coordinates of point B, which are 2, 5, and 3. And once we do this, 3 minus 2 is 1, 2 minus 5 is -3, and 1 minus 3 is -2. Okay, so now we need to figure out what is the cross product of BC and BA first, and then once we have that, we can find the magnitude. So to do this, we're going to need I, J, and K, the unit vectors in the x, y, and z components. Vector BC's components are -3, -1, and -5, and for BA we have 1, -3, and -2 as the components. Okay, to get the cross product, we need to cross out the top row and the column that has I, and then we are going to put I, and we're going to multiply these two together, -1 times -2, that's +2, and subtract it by -5 times -3, which is 15. And then we are going to cross out the j column, and we are going to multiply these two together, and we're going to have negative unit vector j. -3 times -2 is +6, and we're going to subtract that by -5 times 1, which is -5. And finally, for the z component, or the k unit vector, we're going to cross these two out, and we are going to multiply -3 by -3. So that's going to equal to 9, and subtract that by -1 times 1, which is -1. Now we can simplify. We're going to have 2 minus 15 is -13. That's my x component. And then 6 minus -5 is same as 6 plus 5. So that's 11. So that's minus 11j. And then finally I have 9 minus -1, which is same as 9 plus 1, which is 10k. Therefore, in component form, we have -13, -11, and 10 as our 3 components. Once we have all the components, we can go back to the area equation, and the area is going to equal to the magnitude of the cross product. So that's going to be the x component squared plus the y component squared plus the z component squared. Okay, this is going to equal to the root of 13 squared is 169, 11 squared is 121, and 10 squared is 100. And when we add them all up, we should get the root of 390. So to find the final answer, the area is equal to root 390 units squared, and that would be the exact solution. Or you can estimate this if it's a calculator paper on, or sorry, 19.7 units squared. And this is to 3 significant figures. Okay, for the next question, we have to determine the value of x if the area of a triangle with vertices A, B, and C is root 88 units. So first thing we're going to do is we're going to draw it out to kind of get an idea about which vectors we need to work with. So this is going to be A, B, and C. And we can use any of vectors. We can do vector ACAB, BABC, or CACB. I would avoid using vectors CA and CB because C has the x value, which is the unknown value, and then if you find your vectors based on C, then you will have the unknown value in both of your vectors, and then when you do the cross product, it's going to become a little bit of a mess. So let's do AC and AB. I like those two. So we're going to use vectors AB, AC with the angle between, which is theta. And the area, based on the equation that we have found, is 1/2 times the magnitude of the cross product of vector AB and AC. So the first step is to figure out what vectors AB and AC are. So for AB, we're going to take the x, y, and z coordinates of point B, 2, 0, 1, and subtract them by coordinates of A, -1, 1, and 2. And when we do this, we will get 2 minus -1 is 2 plus 1, which is 3. 0 minus 1 is -1, and 1 minus 2 is -1. For vector BC, which has our unknown value, we're going to take x, y, and z coordinates of point C, which are x2 and -1, and subtract them by coordinates of B, which are 2, 0, and 1, and we will end up getting x minus 2. 2 minus 0 is just 2, and -1 minus 1 is -2. Okay, we know that the area is root 88, and we know that we have to use the cross product here and then get the magnitude, and that's going to be in terms of x. And once we have this side of the equation, we can set it equal to root 88 and then solve for the x value. We need the cross product, so I'm going to do that here. Cross product of AB and AC equals 2. I'm going to do my I component, J component, and K components. Vector AB is 3, -1, -1, and vector BC is x minus 2, 2, and -2. To find this, we're going to cover this column and this row, and this is going to equal to the I components. I'll use pink, I component, and we're going to multiply these two. -1 times -2 will give us +2 minus these two. 2 times -1 is -2. That's going to be my x component, and then for the y component, I am going to cover these two, and I am going to multiply these two together. I'm going to get minus j. 3 times -2 is -6. I'm going to subtract that by -1, times x minus 2. For the final component, I'm going to cover up these two, and I will end up getting plus k, and I'm going to multiply these two together to get 6 minus, and multiply these two to get negative 1 times x minus 2. Now I have to simplify a little bit. So for the I component, 2 minus negative 2 is 2 plus 2, so that's 4. And then for the j component, I'm going to have negative j, and I'm going to have negative 6. Negative times a negative here makes it a positive 1. And then I have positive 1 times x and positive 1 times negative 2. So it will become plus x and minus 2. For my k, I'm going to have plus k. I'm going to have 6. Negative times a negative becomes positive 1, and I'm going to distribute the 1 into the bracket. I will get positive x and minus 2. Let's simplify this further. I'm going to get 4 times the unit vector I. I have minus, and then here negative 6 minus 2 is negative 8, and plus x pretty much. And I'm going to multiply that by j, plus here 6 minus 2 is 4, plus x, which is this one, multiplied by k. My components for this vector then become in component form 4 for x, that one is easy. For the j component, I'm going to distribute the negative in, so negative times negative 8 is positive 8, negative times the x is going to be negative x, and for the last one, it's just going to be 4 plus x, and these are x, y, and z components of the cross product. Now, I need to use that cross product and find the magnitude of it, and we know that for magnitude, so magnitude of AB cross AC is equal to the square root of the x component, which is 4 squared, plus the y component squared, plus the z component squared. Okay, I'm going to put the equal sign here, and we're going to do an expansion there. 4 squared is 16, plus 8 minus x all squared is going to be 64 minus 16x plus x squared, plus 4 plus x squared is going to be 4 squared, which is 16, plus 2 times 4 times x, which is 8x, plus x squared, which is x squared. Okay, we're getting somewhere. We're going to simplify this a little bit. We have our like terms are x squared and x squared. That's 2x squared. We have negative 16x and plus 8x. They will add up to negative 8x. And 16 plus 64 plus 16 will give us plus 96. I don't need this to be this long, so I will reduce the size. And that's what we get as our magnitude. Now, we have our magnitude of the cross product of AB and AC, so that's here. We know that the area is root 88, that's given here. I'm just going to write that down here. So root 88 is equal to 1/2 of root 2x squared minus 8x plus 96. Now, we need to solve this. I need a little bit more space. I'm actually going to move everything up here, and our next task really is to solve the value of x. Okay, one thing I can do is, well, the first thing I'm going to do is I'm going to square both sides. And when I do that, I will get root 88 squared, which is just 88. And on this side, I'm going to get 1 over 2 squared. So I have to apply the squared to this and this, and multiply it by root 2x squared minus 8x plus 96 squared, which will just end up being 2x squared minus 8x plus 96. Okay, this is good. I'm going to write this as 88 is equal to 1 over 2 squared is 1 over 4. And here, we're dealing with numbers that all are multiplication of 2. So I'm going to factor out the 2 and then divide it here to simplify my numbers a little bit. So I'm going to factor out a 2 from here, and then I'm going to divide 2x squared by 2 to get x squared, and then I will divide negative 8x by 2 to get negative 4, and 96 divided by 2 to get 48. Now I'm going to write this as 88 is equal to 2 over 4 multiplied by x squared minus 4x plus 48. And I'm going to have 88 is equal to 2 over 4 can be simplified to 1 over 2 x squared minus 4x plus 48. And then I'm going to multiply both sides by 2 to get 176 is equal to x squared minus 4x plus 48. I almost have a quadratic equation. I can get a quadratic by subtracting both sides by 176, and I will end up getting x squared minus 4x minus 128 is equal to 0. Now this is nice because now I can finally solve for my x value. I'm going to use the quadratic formula, and the quadratic formula states that x is equal to negative b plus or minus the root of b squared minus 4ac divided by 2a. My a value here is the coefficient of x squared, which is 1. My b value is the coefficient of x, which is negative 4, and my c value is the constant, which is 128. Now I'm going to plug in all my values here. Negative b is negative 4, plus or minus root of b, which is negative 4 squared minus 4 times a, which is 1, c, which is negative 128, and I'm going to divide everything by 2 times a, which is 1. Now I'm going to simplify this a little bit. Negative 1 times negative 4 is positive 4. Root of 4 squared, which is 16. Negative times a negative is positive, and 4 times 128 is 512. I'm going to divide this by 2 times 1, which is 2. Once I have this, I will have 4 plus or minus 16 plus 512, which is 528 over 2. And now the simplifying game begins. I get 4 plus or minus 520. Root 528 can be written as root 16 times root 33 over 2. That's going to equal to 4 plus or minus root 16 is 4, and I get root 33 over 2, and then 4 divided by 2 here is going to equal to 2, and 4 divided by 2 here also equals to 2, so I get 2 plus or minus 2 root 3 as my possible x values. I hope that this video was helpful in giving you some practice with area type questions, and thank you for watching.